All right, Algebra 2, we're going to go ahead and move on to Unit 6.1. This is on operations of functions. Some of this is going to be review. It's just the notation looks a little bit different, but a lot of this is review from last semester. All right, so we have 4 operations, adding, subtracting, multiplying, and dividing, and we're going to apply those to 2 or more functions. All right, so this first one is the addition property. It says that if you have f plus g, that means the f function plus a g function of x, that can be rewritten. So if you see it like this, f plus g in parentheses of x, that's the same thing as f of x plus g of x. All right, so it just means that you're going to take the f function and add it to the g function. Likewise with the subtraction, same thing. So they can write it 2 different ways. So f minus g in parentheses of x, and that's the same thing as rewriting it as f of x minus g of x. So we're going to take the f of x function and subtract off the g of x function. Multiplication, f times g in parentheses of x. Again, this is just notation. They can write it either way, so I just want you to see that it means the same thing. F of x times g of x. Okay, that means multiply the 2 functions together. And then the last one, division, f over g of x, means the f of x function divided by the g of x function. And because of division, we have to define the excluded value. All right, and so if there's an excluded value, we have to state what that is. All right, so let's look at these examples. So we have these 2 functions. F of x is 3x plus 1, and g of x is x minus 4. And we're going to apply all 4 operations to these functions. All right, so it says take the f of x function and then add the g of x. So that means 3x plus 1 is going to be added to the function x minus 4. Now, with addition, the parentheses is not critical. Because you can kind of see these as just 2 polynomials. We're just adding 2 polynomials, and when we're adding, we can just drop the parentheses and collect like terms. All right, so this is really 3x plus x, which is 4x. And then 1 plus negative 4, that's going to be negative 3. All right, so this is what f of x plus g of x simplifies to, 4x minus 3. Now, when we have subtraction, again, we have these 2 functions, same thing. So we have 3x plus 1. And we're going to subtract off the g of x function, which is x minus 4. Now, this is where a lot of people struggle. If you don't put the parentheses on that second term, you'll forget the subtraction, because we want to make sure that we change that subtraction to addition and distribute the negative. Right? So all the signs on the right side will change their opposites. And now it's just combining like terms. Right? So then we get 3x plus negative x is 2x. And then 1 plus 4 is 5. Right? So subtraction, we have to make sure we distribute that negative to the right side polynomial. And then combine like terms. All right, multiplication. So here again, parentheses is going to be kind of important, because if you're multiplying 2 binomials together, or trinomials, you want to double distribute. All right, so we're going to double distribute, and then we can collect like terms. So 3x gets multiplied over, so that's 3x squared plus, that's going to be minus 12x. All right, and then we distribute the 1. So that's plus x minus 4. And then we can combine like terms. 3x squared minus 11x minus 4. All right, and then division. Again, it's just the f of x function divided by the g of x function. So this is 3x plus 1 over x minus 4. You can't simplify. There's no factoring. Nothing's going to simplify. But we also want to state when is the denominator 0. That's the excluded value. And so we would state x cannot equal positive 4, because 4 is the excluded value to the problem. So you only have to state the excluded value, obviously, when it's a division problem. All right, so let's go ahead and do each of these examples. So we have these two functions. F of x is x squared plus 3x plus 1, and then g of x equals 2x minus 4. And again, we'll do all four operations on these two functions. All right, so adding x squared plus 3x plus 1. We're going to add it to the g of x function, which is 2x minus 4. We'll combine like terms. X squared plus 5x minus 3. All right, subtraction. Again, first functions are f of x function. We're going to subtract off 2x minus 4, so we want to put that 2x minus 4 in parentheses, so we can change it to the subtraction to addition and distribute the negative. And now we can just collect like terms. Again, x squared, 3x minus 2x is 1x. 1 plus 4 is 5. All right, multiplication. We want to use parentheses on both of them this time. And here we're going to distribute. So we'll take the x squared and distribute that over. So that's 2x to the third minus 4x squared. Then take the 3x, distribute that over. That's 6x squared minus 12x. And then lastly, take the 1, distribute that over. And then we'll just collect like terms. All right, that's it. We're not factoring this, so don't, even though there is a GCF of 2, don't factor anything out. You're just combining like terms. All right, and then last one is division. All right, so the x squared plus 3x plus 1 goes on top. 2x minus 4 goes on the bottom. All right, now we want to try to factor x squared plus 3x plus 1. Again, it's a trinomial, so if you put 1 on top and 3 on the bottom, there's not two numbers that multiply to 1 but add to 3, so the top doesn't factor. The bottom, 2x minus 4, we can factor that. We can pull a GCF out. All right, so I'll just rewrite the top. Bottom, I can pull a GCF out. Nothing cancels. Now I do want to state any excluded values. There is an excluded value to this problem, and you can see from that x minus 2, x cannot equal positive 2. So this is how we would write our division answer. All right, example 2. All right, so we're going to add f of x and g of x together. So we combine like terms. X squared plus x minus 2. You don't have to worry about factoring because we're not trying to cancel anything out here. We just combine like terms. Okay, subtraction. Again, make sure that second function, put it in parentheses. And that's so you can change the subtraction to addition, distribute the negative, and then collect like terms. Right, that's minus x now. Negative 4 minus 2, that's minus 6. All right, multiplication. Here we want to put both binomials in parentheses. And we'll double distribute on this one. Doesn't look like there's any like terms, so that's it. Okay, division. All right, we can factor the top. Okay, we can simplify this. Now, we do have an excluded value, and so remember, you got to take it from the original before you factor or cancel anything out. So that's going to be -2. So x is not allowed to equal -2. All right, composition of functions. So this is where we substitute one function into the other function's variable. All right, and so when we do this, we want to kind of think of working right to left, because you got to work from the inside parentheses out. So we're working right to left. And so we have this symbol when we're talking about a composition. It's this open circle, right? And so we also call this a fog problem, F-O-G. All right, and so when you see this composition with that circle in between F and G, you can actually push them all together so it looks like this instead. All right, F of G of X. So F parentheses G of parentheses X parentheses parentheses. All right, so that's called fog of X. You can see it in two different ways. And same with G of X. So if you see G circle F of X, that we also call that GOF. Okay, and so when you have that, you can push those together and you get G parentheses F of parentheses X. All right, so if the little circle there for the composition, that symbol messes you up, just think of pushing it all together and seeing it the other way. So the equation that's on the right side instead. All right, so let's go ahead and do these two compositions. So we have this f of x equals 2x squared minus 5 function, and we have the g of x equals 3x. Right? And so we're going to go ahead and find a fog of x, that's that composition, and then GOF of x, that's its composition. All right, so again, I would rewrite this just so it's easier to see. If it's not done for you, then I would just kind of rewrite it like that instead. All right, and then GOF of x, same thing. Okay, g of f of x. All right, so we have this g of x function. All right, so we're working on the inside first. So we're going to replace the g of x with what its function is. All right, so we're just taking the g of x function, which is 3x, and we're going to put that there instead. So we really have f of 3x. So now what we're going to do is take this 3x and we're going to substitute it into the f function for x. Okay. So again, we're just going to take this 3x and we're going to substitute it in for x in the f function. So now we have 2 parentheses 3x, and then that's being squared, and then minus 5. All right, so again, all I did was take the g of x function, which is 3x, and substitute it in for x in the f function. All right, and now we can simplify this a little bit. Remember order of operations, we have to do 3x squared first, so exponents have to be done first. So 3x squared is 3x times 3x, which is really 9x squared. Now I can multiply 2 times 9x squared, that's 18x squared minus 5. All right, and so that's what it simplifies to. Now, it does state the domain. All right, so the domain is of the final answer. If you look at the, find the domain of the original function, f of x equals 2x squared minus 5, and then the domain of the second function, which is 3x. So you want to find the domain of both of those. Okay, so 2x squared minus 5, that's just a quadratic. It's a parabola, and its domain is always negative infinity to positive infinity. And then g of x equals 3x. Y equals 3x is just a line. And if it's a line, the domain is also just negative infinity to positive infinity. And if you take both of those domains, they're both the same. So that means the final domain answer, 18x squared minus 5, is also going to be negative infinity to positive infinity. All right, and then let's do B. All right, so we're doing g of f of x. So again, we're going to take the f of x function, and we're going to put 2x squared minus 5 in for it. So we have g of 2x squared minus 5. All right, so again, I just replaced what f of x was. It's 2x squared minus 5. So now I'm going to take the 2x squared minus 5, that whole thing, and I'm going to put it into the g function this time. So again, over here, if you look, the g of x, the f of x function was 2x squared minus 5. So I'm taking 2x squared minus 5, and I'm going to substitute it in for x in the g function. Okay. So that's what I'm going to do here. So it says do 3 times whatever you're substituting in. So it's 3 times 2x squared minus 5. All right, now I can distribute the 3 in. So that's 6x squared minus 15. All right. And then again, since the domain for both functions are the same, negative infinity to positive infinity, the domain would be the same for this also, negative infinity to positive infinity. And all the ones that I give you, just so you know, if you ever are asked this question, what's the domain of the composition, log of x or gof of x, the domain is just going to be negative infinity to positive infinity. Okay. All right, example 4, evaluate each of the functions given. All right, so we have here are 3 functions. So we have f of x equals 4x, g of x equals x plus 5, and h of x equals x squared minus 9. And so we'll just do each of these operations, whether it's adding, subtracting, multiplying, dividing, or a composition. All right, so question A, find f of 3. All right, so we're going to look at the f function, and it's f of x equals 4x, and so it wants you to find f of 3. So that means we're going to plug 3 in for x, right, into the f function. So that's going to be 4 times 3, because it says do 4x, 4 times what x is. Right. And so then that means f of 3 is equal to 12. All right, so all this really is just a series of substituting in for x. Okay, B, find g of negative 4. All right, so here we take the g function, and we're going to put negative 4 in for x. So negative 4 plus 5. All right, and negative 4 plus 5 is positive 1. All right, C, find f of 2 plus g of negative 3. All right, so here we're going to find f of 2 first. So that means we're going to plug 2 in for x in the f function. So that's 4 times 2 plus, and then we're going to plug negative 3 in for x in the g function. So that's negative 3 plus 5. All right, so then this is 8, and this is 2, and then 8 plus 2 is 10. All right, so find the value of each function separately, and then do the adding or subtracting or whatever they want you to do. All right, so D, find h of 1 times f of 5. All right, so we'll plug 1 into the h function. All right, so that's 1 squared minus 9. And then we're going to multiply that answer by what f of 5 is. All right, so that's 4 times 5. All right, so again, do each one separately, and then we'll multiply the answers together. All right, so 1 squared is 1. 1 minus 9 is negative 8. Okay, times 4 times 5 is 20. Negative 8 times 20 is negative 160. All right, E, find f of g of 1. All right, so this is a composition. All right, so that means that we're going to find g of 1 first, because you have to work on the inside parentheses. And let's see, there should be another parentheses right there, second parentheses. All right, so we're going to find g of 1 first. So it says plug 1 into the g function, so that's 1 plus 5. So that says f of 6. So now we're going to plug 6 into the f function. So f says do 4 times x. And so that's going to be 24. All right, find g of h of 0. Okay, so again, should be another parentheses on that. So we're first going to find what h of 0 is. All right, so plug 0 in for h in the h function, or plug 0 in for x in the h function. All right, so that's x squared minus 9. So we have g of 0 squared minus 9. Okay. So we'll simplify that down. 0 squared is 0, 0 minus 9 is negative 9. So now we're going to find g of negative 9. So we put negative 9 in for x in the g function. So the g function says do x plus 5. So there's our x plus 5, and that's negative 4. All right, g, gof of 3. So again, that means g of f of 3. All right, so first we're going to find what f of 3 is. So plug 3 in for x in the f function. So f function is 4 times x. So 4 times 3. And now we're trying to find g of 12. So put 12 in for x in the g function. All right, so our g function I have to fix question f because I plugged it into the wrong one. No, I didn't. F is good. All right, so let's finish g. G of 12. So g function is x plus 5. So that's 12 plus 5, and that's 17. All right, and last one, h of g of negative 6. All right, again, you could rewrite it as h of g of negative 6. So we're going to find g of negative 6 first. So we'll put negative 6 in for x in the g function. So x plus 5. So h of negative 6 plus 5. So that's h of negative 1. Now we'll put negative 1 in for x in the h function. So that's negative 1 squared minus 9. So that's 1 minus 9, which is negative 8. All right, and that should be it.